Okay, hello everyone. My name is Park Poomruenchan from Department of Physics. I will introduce you the experiment number 6, physical pendulum. In this experiment, we will do the experiment about the rotating of object about the pivot, and we will use the physics law to determine the moment of inertia of any shape object, the geometric object, for example, the rod or the disc. Okay. Okay, I will start with some theory about it. For example, if we have an object in this shape and we hang it with something, this is a pivot, and if we can determine the center of mass is here, and if we can measure the distance between the pivot and to the center of mass is d, okay, and if we move it a little bit from its equilibrium, so there will be a restoring torque which come from the gravitational force, which is mg here. This is mg. So this mg will cause you the torque. The torque is here, equal negative mg d sine theta. Okay, and if we use the Newton's second law, it will be equal I alpha, where I is a moment of inertia and alpha is the angle acceleration. Okay, so I will not solve this for you, and then finally we can get the moment of inertia in this form. Yeah, you can do it at your home using the Newton's second law and the second derivative equation. So finally we will get the omega is a angular frequency, sorry. The angular frequency equals square root of mgd over I, and then we know is equal to pi over t. T is a period of rotation. So finally we can get the moment of inertia in this form. It means that if we know the mass, the gravitational acceleration g, which is equal around 9.8 meter per second square, and d we can know from the measurement, and also t is a period of rotation. We also can measure from the experiment, so we can determine I. So finally, if we know I, we can compare with some other theory. The I will have the unit of kilogram per meter square. Okay. The another important theorem in this experiment is a parallel axis theorem. So in this theorem, it said that if we know the moment of inertia around the center of mass of any object, but usually it will be the geometric object, for example disc or metal stick, and we can determine the moment of inertia around any pivot point or rotating point by using this equation. This is the moment of inertia around the center of mass, and this is mass, and d is determined as the distance between the center of mass and the pivot point d here. Okay, and d will have the unit of meter, and m have the unit of kilogram. Okay, in this experiment we will study the parallel axis theorem for disc and the metal stick. This is an apparatus we use in this experiment. We have the stand and clamp. We have watch to count the time for the rotating of the object, and we have the balance scale to measure mass, so we can determine mass here. We can determine time period, and yeah, and we have a disc, we have metal stick, and we have any shape wood plate here and tape to put to stick the paper around the wood shape plate. Okay. At the beginning, we have to find the center of mass of any shaped wood plate by using the plumber. The plumber, or in Thai is looking. Okay, we will put the plumber here. This is a hanger. First we wrap the wood shape, the any shape wood plate with the paper. Okay, we wrap it with the paper and put some Scotch tape on the back, and we hang it at any point. We hang it, and then we put the plumber. And then in the principle, if we wait until it stays still or in the steady state, this line should pass the center of mass somewhere. It should pass the center of mass, which is somewhere in this line, and then we change the hanging point from this point to this point, and then we do it again. So now we have two lines. First we have this line, right? And second we have this line. Okay, and we do it again. So finally we will have three lines, which we can determine the center of mass here. Okay. Next, we measure the weight of the wood plate by using the balance scale. Okay, you can click here to see the demonstration how to use this balance scale. Okay, we measure the weight of any shaped wood plate, disc, and the meter stick. And this is the important part. We determine an average period of rotation. So at this session, we need to select one of the pivot point, and then we measure D. For example, the pivot point is here, so we measure D. D is the distance between the pivot point and the center of mass. Okay, you can see the video demonstration here. And if when you doing the experiment, you pull the wood plate with a very small angle. In this case, I use the angle less than 10 degrees. Otherwise, your experiment might be not so accurate. Okay, and again you redo the experiment, but now you change to the disc and the meter stick. You can click here and here to see the demonstrations. Okay, after you get the information, you record the time of the period of rotation using this table. For example, if you can count the cycle of rotation here for 10 rotation, maybe you can get rotation here maybe 18 point something, I don't know, and this maybe you get 89 point something, and then you determine T is period of rotation, so T should be equal T over 10 or T over 20, depend on which space you want to fill. Okay, please remember the capital T is a period of rotation, so it means one round of rotation, how much time did the object use. Okay, and then you do it for this, and then the meter stick, so you can find an average here, here, and here. This is a T, period of rotation. So once you get mass, you get D in meter, you get mass in kilogram, you get D in meter, and you get capital T in second, you can determine the moment of inertia using this equation. Okay, this is from experiment. And next, now we focus on the parallel axis theorem. In this part, we will test this theorem to the disk and the meter stick only because it's a geometrical shape, so we can determine the moment of inertia around the center of mass. Okay. For example, you use a disk and then you can record the mass here, and then the R is the radius of the disk, and D is the distance between the pivot and the center of mass, and then you can calculate moment of inertia using this equation, and then you can calculate the percentage difference by using this equation. Okay, so you can compare the moment of inertia from the experiment that you let it rotate around the pivot point, and with the moment of inertia from the parallel axis theorem. This value should be not so different. Okay, in principle it should be close to each other. Oh, I'm sorry, this should be the absolute value. Okay, should be absolute value, so it means it has to be positive number. And then you show the calculation for the meter stick. Okay, you show the calculation for I experiment, for I parallel, and then the percentage difference. Okay, that's all. Thank you for watching. I think I have a wrong pronunciation for the word pivot, which I said pivot many times, but actually it should say pivot. Yeah, you can check in your English book, or you can Google it. I'm sorry about that. Yeah, this kind of difficult word. Okay, see you next time.